I'm Ben Stone. I'm a lead consultant at Big Compass. I've been working on MuleSoft for about 2 years now, and I sort of immediately liked it. Just in the last month, I got my platform architect and my integration architect certifications. So now I have the full trifecta of all three MuleSoft certifications, and I'm excited to be presenting at this meetup again. Um, I've presented here twice before, um, on previously on batch and data synchronization and replication, and I've been at Big Compass for the last year and a half. Love board games and rock climbing, so if anyone wants to talk to me about those later, I'm always open for it. And I'm always happy to answer any questions that anyone might have about any of this. For this meetup, we're going to be talking about what's new with DataWeave. DataWeave obviously being the functional programming language at the core of MuleSoft, which I think is probably one of the most interesting aspects of MuleSoft. It's not often in most jobs that you get a chance to play around with the functional programming language that is actually doing things. And we've had two updates to DataWeave 2.3 and DataWeave 2.4 come out over the last year, or part of the last year, both with some pretty useful features that I've found have definitely made a fair amount of things easier in DataWeave. So we thought we'd take this time to go through some of those features, talk about them, talk about how they might be useful, and sort of explain some of the more esoteric ones that might come up and might be a bit hard to understand just looking at the release notes. This is going to be something of a grab bag of different topics, different questions. So I'm very happy to stop at any point and talk if anyone has more questions about a specific aspect of this or wants me to go more in depth. I'm very happy to do so. Put that in chat, and Brian, Linda, or Stephanie will let me know to take a look at that, and I'll answer that. And then we'll have some trivia throughout. So what's new with DataWeave? Four main things we're going to be talking about. The biggest is the update operator because it has made my life so much easier. We'll talk about some convenience functions that are somewhat edge cases but can be useful if you need to do something specific. There are some new reader and writer properties that we'll talk a bit about. You may remember Josh's presentation from a couple months ago about DataWeave readers and writers and how they can be used to do more powerful things in DataWeave. And then finally, we'll take a look at two new modules that DataWeave has added, the math module and the coercions module. So to start off with, the update operator. The use case for this is if you want to update a single field in a large object. Previously, your options were basically to copy the entire object field by field over into into your new object. For example, here, if you want to update assignee to pick up a value from a variable, there's no good way to just update that one value, or there used to not be. You could get slightly more efficient by using map object. Here, for example, we have a map object that's iterating through all the keys in an object, checking to see if that key matches the one we're looking for, and then updating that key specifically. And this works, and this is more efficient, but it does have some edge cases that you may not want, or you may want to be aware of. And it's also not necessarily the easiest to read or the easiest to understand what this is doing. If you're skimming through someone else's DataWeave code and you see a map object, you tend to assume that they're doing some sort of large edit on the object and not just updating the value of a single key. So having a better way to do this would certainly be helpful. The problem here is that DataWeave is a functional language, as I mentioned, so we don't have declarative statements that let us just update a single value. If you were in Java and you wanted to update a single value out of an object, you could write a pretty simple line of code that just changes that value. The problem in DataWeave is because it's a functional language, the output of of whatever piece of code you need to write isn't the entirety of it. You don't have this sort of external object that you can go and edit. You need your output to be the entire thing. And because you need your output to be the entire thing, you need to use one of these sort of transformations where you copy everything over, or a map object where you search for the key. You'll note in this map object, for example, every key that isn't a signee is also being copied with this last key value part. So everything else is still being copied over, and you still have to do that. Since it's a functional language, you need that entire output. But now we have the update operator, which does all of this in the background, does all of it for you. It's pretty easy to use. You just need to specify a field that you're searching for and a replacement value. And remember to import it from the values module. Whenever I'm looking at something new in DataWeave, I get excited to play around with it, write some code, and then I'm confused about why it's not working or why it's not recognizing it without the import statement. Might just be me. In this case, we have our example, the small object with a couple different fields. Here we want to update the assignee, and we can do that with a simple update notation. Example, update assignee with the value. That value could be dynamic, it could be pulled from a variable, it could you can do a whole variety of things with this, and it very much obviates the needs for those sort of complicated but basic transformations that we had previously. One of the ways that we can get a bit more complex with this is by using an expression to determine the values that we're updating. This isn't super well documented in the DataWeave documentation, if you look there. So hopefully there will be some more added to that soon. But there is certainly some examples of it there, and some very good blogs from MuleSoft that are written on this update operator. You may recognize this case structure from the match operator, which is sort of DataWeave's case and match operator, where you have a series of matching statements to see what to edit about your object. In this case, you don't use match, but you instead use update, and everything else is effectively the same. So in this case, we're looking for the variable assignee, and we're looking for the key assignee inside of our example object, and we're assigning that value to the variable assignee, which again could be injected from somewhere else in your code. You can also do more dynamic things with this. Similar with the case and match operator. You can, for example, conditionally on the value of one of these key value pairs, you can edit it in some direction. So in this example, we're incrementing age by 1 if it's less than 10. And so this sort of conditional update lets you get a lot more flexibility than you would using any of those prior structures. Allows you to apply these updates in a much more fine-grained basis. Eventually, you might get to a point where you just want to create an entire map for the entire object. There's sort of a trade-off at some point there. But as long as the things you're updating are a sort of small subset of the overall object, the update operator is going to be a lot more efficient than creating that overall map. And from a readability perspective, it also works much better since you don't need to wonder where in the whole input object these edits are going. You can see exactly what changes are being made. You don't need to sort of manually compare each input and output to see if the code changed them. You can also do upserting. So in this case, if you aren't sure if a value is going to exist in your input object, then you can do an upsert where if it doesn't exist, it's added in, and if it does exist, it's edited or replaced, updated with your new value. So in this case, we have an example that does not contain an assignee field, and what we're doing is we're going in, checking to see if that example contains the assignee field, and if it does not, adding it in. That exclamation operator is the important one here, that checks this, that makes it do this update even if it can't find the assignee originally. If you don't have that there, then this will error. It will error if there is no assignee. If it's doing an update, of course, it'll just work normally. So that's a sort of niche use case of this, but it can definitely be useful. I definitely found myself at certain times wanting to be able to upsert something into an object. We got our first trivia question here. What is the output of the following data weave? Where we've got two different update statements. Or two different update cases.
We'll just give them a few seconds to enter their answers on the trivia question here.
Yeah, sure thing.
I think this may be a trivia question first, Ben. I've actually seen all 4 letters chosen here, but most of the choices are D and A. So I think we've given you enough time. Go ahead and which is the answer and why is it the answer?
So the answer here is going to be A. So I believe what I'm seeing is Luke Hamilton first.
Luke Hamilton is indeed the first one. Yes. So why is it A?
To you. So we've got two cases here. First, looking at the assignee, we are updating it if possible, and in this case, it isn't. If it's found, and if it's not found, we would be adding it in. It was found, so we're taking from the variable and inserting it there. So it's going to be Alice. That narrows it down to A or B. The second line, this case ID, add ID. So in that case, again, we're looking to see if the ID key value pair exists. If it does, we are taking the value of it, calling it ID, and then we're comparing it to this ID limit, which seems to be set at 5. Since 17 is greater than 5, we will indeed deprecate it by 1, decrement it by 1, so our new ID will be 16. So congratulations to Luke.
Great, Luke. Go ahead and DM us your email address, and we will be sure to send you the form.
Awesome. Anyone has any further questions on that? Happy to answer. Otherwise, we'll move on. Second sort of category of things that I want to talk about are some convenience functions that were added over the last couple updates. First ones are some generic accessors, the values of and names of. So what these are is looking at an object, you have at a core sort of a set of object or key value pairs. And sometimes it's very useful to be able to manipulate and work with those key value pairs directly. So the values of gives you an array of values of the object without any of the keys, just set into an array. And names of does the other thing where it gives you the names of the keys. There's a couple things to be careful of here. There is another function called keys of. This gives you an array of keys, and the output of names of and keys of looks identical. And this has been some debugging frustration for me multiple times. I'm not sure why I can't get this into my head. Keys of returns a set of type key, and it looks like strings and it prints out like strings, but you can't compare them to strings unless you coerce them into strings. And they coerce just fine, they're just like strings, but it is something to be careful of, where you might be doing some comparison and getting a negative result because you're trying to compare the key called Alice to the string, or the key called name to the string name. Caught me up multiple times, something to definitely be aware of. One place I've seen this come up quite a bit, for myself at least, is with the group by operator. So as a quick refresher on that, the group by operator takes an array of data and sorts it into several buckets depending on the criteria you give. So in this example, we have a group number for each of these objects inside this array. So group by will collect all of the objects that have the same group number into one bucket. You can see on the right, the structure of the output of group by has always struck me as a bit weird, but I also can't think of a better structure. So this makes sense to me. So it makes sense to me why it's like this, but it also always catches me off guard a bit. The key here, 1 or 2, is the value of the conditional that you're using to sort these. So whatever set of buckets you've got, it's going to be, the keys here are going to be the values of each of those buckets. So whatever item.group outputs, that's how it's going to sort these, and that's what it's going to name each of these arrays. So this object that group by outputs is a object with several keys, each key is a group, and each key's value is an array of objects from the input array that match your criteria. Obviously, it's a bit hard to exactly specify, but it also makes a lot of sense if you actually look at what's happening. So everything with group 1 gets sorted into this array. Everything with group 2 gets sorted into this array. But since you have this sort of weird nested structure with the ID or the groups as the key names, sometimes you might have a structure like this and need to do something with this. So I might need to iterate through the groups or print out a list of all the different groups. And you can certainly do that with distinct by. In DataWeave, there's always a couple to a dozen ways of doing any specific thing. So you can do this in multiple different ways, but it is useful to be able to take those values out of the key names and back into an array for you to manipulate. That's sort of the most common case I've used names of for. So these names of and values of operators, definitely useful. These are these and the update operator are probably the ones from this presentation that I've used the most of. It definitely does get a bit more esoteric as we go through, but these ones are very useful and could come up in almost any project. One other common thing that they've improved a fair amount over the past year is string manipulation. One of the sort of common problems I see people having is not being quite sure how to do substring selection or substring manipulation with DataWeave. DataWeave sort of treats a string just like an array, so you can use the way to, up until this year, the way to do a substring was just like you would pick out a subset of an array. So we're just taking the indices 1 to 5. It uses the same notation, but it was confusing to look up, and it was also confusing to people just coming to DataWeave. So they added in a couple substring methods that do effectively the same thing, but make it a bit more explicit, a bit more easy for people coming from other languages to understand. There's also some utility functions. Substring by is basically the same as the split by function, which splits a string into an array of strings based on whatever character you give it, whatever matching conditions. So it could split on spaces, it could split on dashes, that sort of thing. And substring every splits a string into an array of equally sized strings. So every 3 or every 5, etc. One even more convenient option is the words function, which actually splits it down into words, sort of no matter what the dividers are. The dividers it recognizes are spaces, tabs, and new lines. But you can see with the sentence here, it's definitely useful to be able to instantly split into the individual words. Though do be aware, you can see that punctuation, like commas and periods, just gets combined into the whichever word it happens to be adjacent to. There's also the lines function, which does a similar thing, but only splits on new lines. Starting to get back into some things you may have learned back in math of computer science. They've added functions for the Hamming distance and the Hamming distance and the Levenshtein distance. The Hamming distance between two strings is the count of specific indices where those strings are different. It's not well defined if the strings are not the same length, because if you pad at the beginning versus if you pad at the end, you would get entirely different results. So you will get null if you try to use the Hamming distance on strings of different length. But the essence of it is pretty straightforward to understand. You're looking at each index of the string at each letter and comparing it to a second string wherever it matches. You continue on, and wherever it doesn't match, you add 1 to the count. The Levenshtein distance, however, is a bit more of a complex measure. Hamming distance tends to be used in sort of bitwise comparisons. It tends to be used to be able to detect noise or detect errors in transmission. You may have heard of Hamming codes, are a sort of application of that. The Levenshtein distance is more specific to strings and words. Sort of defines the edit distance between two different strings. And an edit in this case is a substitution, so a transformation of one letter to another, deletion of a letter, or an insertion of a letter. So you can see, for example, the Hamming distance between these two strings, 0, 1, 2, 3, 4, 1, 2, 3, 4, 0. The Hamming distance is 5 because in every single index, they don't match up. The Levenshtein distance, on the other hand, is just 2 because you just have to delete the 0 at the beginning and insert it at the end. Definitely esoteric. I haven't used this yet in my job, but I do remember learning about this, and it's sort of an example of the more specific functions that they're adding to do specific things.
Hey, Ben, before you move on, there was a question about your words example. Keisha asked, does words also output double quotes if there are any? Like your example, you got a comma in there, so outputted the comma, but how about double quotes?
So the double quote is escaped. Let's see, I'm not sure. I can switch over real quick to DataWeave Playground, and
yes, I want to see you break DataWeave. I want to see you break DataWeave Playground. So yes.
Brian's been teasing me for days since both of my last presentations. Wildly weird things happened to my demos, so we shall hope that the DataWeave Playground is strong enough to withstand this. here we're importing from strings, and we have a sentence. Does run import core.
Somebody.
There you go.
Yeah, there it is on the escape right there. Oops.
Yeah, so we'll include it as a character. Yeah, it just treats it as a character. Essentially, this is doing a split by where the matching expression is space, tab, or new line, or any multiple of those. So you can imagine making a regex with that to look for that. So you could do this with the normal split by, but this is a nice common use case that'll come up a fair amount. Does that answer your question?
I'm going to assume it does.
Cool. I will go back to the other tab then. Awesome. So I believe we've got our next trivia question. Which of these pairs of strings has the smallest Levenshtein distance? And you're back to math of CS. Who is quickest to calculate it themselves?
I think you did it again, Ben. I see all your letters listed, and there's it looks like most people have chosen B and C, but we do have like one A and a D. So, which one is the answer, and why is it correct?
The answer is actually the last one to be posted. So C, Andrew got it. Mantra and Manta, or Mantra and Manta. Kitten to sitting, this was actually the example on the previous slide. There's 3 steps to transform it. S to K, I for E, and then add a G on the end. Start to tarts, this one's a bit trickier. You can't, if you remember, moving one letter, that was not one of the operations that was allowed. So we have a deletion of an S and an addition of an S on the other end. Mantra to Manta is just one, just remove the R. And alert to advert, you transform the L into a D and add a D in. So we've got 2, 2, A is 3, C is 1, B is 2, and D is 2, making you see the correct answer.
Great. All right. Well, we'll get Andrew's email and go ahead on.
Awesome. I always love a trivia when the wrong answers are close enough to be possibly right.
That sounds like a MuleSoft certification exam.
I was inspired. On to some reader and writer properties. I believe I saw Josh on the in the chat earlier. So he's certainly more of an expert than I am, but the reader-writer properties in DataWeave are sort of core to how these transformations work. You don't need to use them, but oftentimes if you're trying to do something specific, you got some edge case on exactly how you want your output to come out, the reader or writer properties can help you there. So they've added a couple new ones in for specific cases. The first one is for the DataWeave reader, and the DataWeave format is the sort of canonical format that everything goes through, but most people won't generally be using that in their projects, but you may come across it, and there are some interesting things being done with it. I'd encourage anyone who's curious about DataWeave to check out the newish annotations module in DataWeave, which I certainly haven't explored very extensively, but has some very interesting things you can do with annotations, like deprecating functions, limiting the privileges of functions, or doing things like specifying tail recursion so that DataWeave will attempt to unwrap it and optimize it into an iterative function rather than a recursive one. This privileges is tied to that, so you can restrict your reader's access to specific things. The most common example would be resources or properties. You can prevent a bit of DataWeave from reading properties from a properties file, for example. The Excel spreadsheet reader has a new table limit feature. This again goes in the header, the sort of DataWeave header, and limits the columns that your reader pulls in from the sheet. So if you have a sheet that you only care about a couple of columns of, you can set this table limit to only read in those first few columns using that column name option, that first option. You can also set it to header size, which will read in all of the columns that have headers, and any columns that don't have headers won't be read in, or unbounded, which is the default, which will read in all the columns. And then the YAML writer, this one is pretty specific, but you now have the option of whether or not you want to include the YAML declaration at the top of it with the write declaration writer option. The XML writer also has some enhancements related to namespaces. So I'm sure some of you have run into this where you want to write out some XML for a specific, for another system to use, and it requires some root namespaces. Previously, there wasn't a great way to do that programmatically, but now you can both set the default namespace for an XML document and also write some declared namespaces into the root node of this XML document. The write declared namespaces is pretty flexible. You can write every namespace you have declared. And as a reminder, over on the left here is how to declare a namespace in the DataWeave format. So this is you have this NS in the DataWeave header, and you can write all of them, write specific ones with a comma separated list of IDs, or you can even set up a regex to match specific namespaces that you want to write in. That's all for reader and writer properties. Again, pretty specific, but useful for the right cases. So the purpose of this presentation is, again, to sort of give you guys a brief flash of all of these different things so that if you run into one of these use cases in the wild, you can think, oh, there's an easy way to do this rather than brute forcing through it. The two new modules in DataWeave are the math module and the coercions module. Math is pretty simple so far, but is much easier than doing it by hand. They added in basically functions to cover sort of specific cases that aren't easy to replicate with any other mathematical functions. So sine, cos, and tangent, arcsine, arccos, and arctangent are all functions that are now added in and can be referenced. So if you need to do some sort of mathematics in your transformations from one format to another, those are now no longer have to use approximations or a call out to Java or something like that. For logarithms as well, there's the log10 and log_n functions. Only those two are the base ones, and it doesn't give you an option to specify a base, but there's pretty straightforward change of base formula to switch from one base to another using logarithms. If you have a common base, just divide your value by the base you want it in. It was probably a poor explanation of it, but we're getting wildly off topic. Note that you can get any base logarithm using this. There's some functions for conversion between degrees and radians, which can be helpful to use with your trigonometric functions. And finally, the e and pi constants that will be useful in different instances. I haven't found myself doing a lot of math with DataWeave, but it's certainly better than having to call out to Java in the rare cases where it does come up. The other module is the Coercions module, which is the set of about 20 different functions that will attempt to coerce one value to a different type. And it's all the ones you might expect it to be, and they work pretty much exactly like you would expect, converting the string false into the Boolean value false, converting time zone strings into time zone values. It's in a lot of these cases, in the past in DataWeave, you could get this sort of coercion by sort of implicitly doing it, or by setting something like as string or as date. And those are still useful, but it's also good to do these, in cases like this, it's good to do these explicitly to make sure that you're not accepting data that might be transformed weirdly by your coercion. So sort of making your assumptions explicit can really help with debugging and can help with running into some edge cases. I've got an example here of some time zone conversions using the Coercions module. The two time zone can take any different way of representing it. Like I said, these are pretty flexible. Basically, if you would expect it, if there's one reasonable thing for it to do, it'll do that. So I figured it would be a good use of all of your time for me to go through all 20 or so different coercions, but just have in the back of your head that if you do need to coerce between different types, there's now a specific module for it. One note also is the tilde equals operator, which does comparison between two values and attempts to coerce them to the same type if they're not. This is another way to get around that problem I mentioned earlier with key names and key names as strings. There's definitely cases where you need to be comparing things of different types that are pretty obvious to compare to a human, but you need to tell the computer explicitly how to do it. Do be aware again, when you're using this, it's not super visible. You're not being very explicit about what you're doing. So if you get some weird values in and the coercion does something funky, something to be aware of, something to be just sort of keep in your mind, something to be aware of. But it is very useful to have this sort of forced comparison operator. And that brings us to our final trivia question, which is a bit of a collection of different things from throughout this. Which of these snippets of DataWeave does not produce the same output as the others? There we go.
Ben, you don't. Oh, there we go.
For some reason, they were on a different.
At first, I didn't see the choices.
Yeah, for some reason the choice boxes were on a different transition. Not sure why.
It was that. So when you mentioned all those math operators, you brought back terrible memories of trig. just want to point that out. It's like, no.
Yeah, I've got fond memories of trig. I always liked. I thought it made sense. The bad part was when you had to start doing trig with non-right triangles, with like law of cosines and law of sines. That was the frustrating one.
All I know is all the math I took, and then when I started doing programming, I was writing device drivers. So all I had to worry about was being able to count to 16.
Looks like most people are getting it correct. This is indeed B. The nested key inside C is not counted as a key of example. The others are pretty straightforward. We're replacing 6 with 3 and a bit of math. 10 cubed is 1,000. So I believe congratulations to Siva.
Siva, yeah. Siva Surya, yep. Hope I didn't butcher your last name too badly. Siva, if you could DM us your email address, we'll be able to send you the link.
Awesome. So that's all of the varied DataWeave updates to take you through. I am happy to dive more into any specific things. If any of you have questions, I'm happy to answer them. Otherwise, I will hand it over to Brian and Stephanie for talking about the future meetups.